Okay, this is on 5.4, and we're talking about logarithmic functions and equations. So when we talk about logarithmic functions, we have to know exponential functions because they are very related. So a quick review on exponential functions. It's of the form, f of x is equal to a to the x, or we write that as y to a to the x. So this is a number raised to x, okay, equals to y. So make sure you remember that. And the 3 points, like we talked about, the 3 points that we use is -1, 1 over a, 0, 1, 1a. Always, these 3 points are very important. It helps you find the center of your graph. And then the domain is always all real numbers. The range is y is larger than 0. And the horizontal asymptote is y is equal to 0. So, and then they give you, with a bunch of other numbers like c, h, and k. And sometimes they put a negative in front of x as well. So make sure you know what all these things do to your parent functions. Okay, this is the previous section that we did. So make sure you know that before you do this one. So the definition of logarithmic function is like this. You have y is equal to log base a of x. And what that means is you can flip this into an exponential form. This means that a to the y is equal to x. Okay, so these two are basically the equivalent. Okay, they are different forms of each other. This first one is called the log form. If they give you log, you should understand what that means. Okay, they're saying that what number is x, so that when I raise y or a to the y gives you x. Okay, so these two are the same. One is log form, one is exponential form. And we read this as log base a of x. So this should be reviewed. You guys did this in algebra 2, but if you don't remember, make sure you learn that now, okay? So if they give you a log form, you have to be able to change that to exponential form. And if they give you exponential form, you got to go backwards to log form, okay? So example A here, I have log base a of 4 is equal to 5. They're saying what number is a so that when a raised to the 5th power gives you 4. That's it. That's what log means. Log is asking for the power, right? 5 is the power of a. A to the 5th power is equal to 4. Now, when they give you exponential form, you can go back to log. This is log base 1.2, right? Base 1.2 of m equals to 3. So it's saying 1.2 raised to the 3rd power is equal to m. So go from exponential form to log form and log form to exponential form. You got to be really fluent with that. Okay, another one here. I have 2 raised to the y is equal to x from this form. See, 2 raised to the y equals to x. That's the relationship. This one here, this is going to be log base a of 5 is equal to 3. Okay, so it's a pattern that we just have to memorize. All right. Here, this is log b equals to 4. This one doesn't have a base. Okay, so when they don't write a base, the base is 10. Okay, so if they don't write a base, pretend that there's a 10 there. It's invisible. There's a 10 there. So when you change this to exponential form, it's 10 to the 4th power is equal to b. Over here, I have 10 to the b is equal to the 15. So when you change that to log, just write log 15 is equal to b. Okay, because I don't need to write a 10 there. I don't need to write base 10. You write log, people understand that this log base 10. Another one is ln of a is equal to -4. Ln, it just means log base e. And e is a number that we'll discover at some point. Okay, but not right now. Let's just assume that e is, 2 point whatever, 718. So ln of a is log base e of a. So when you change that, you have e to the -4 is equal to a. Here you have e to the x is equal to 5. Change that to log. Don't use log, use ln because it's base e. So ln of 5 is equal to x. So these are the two special cases of log. Make sure you write that down. Log base 10 is log with no base. log base e is ln. Okay, make sure you remember that. All right, so let's talk about the function. F of x is equal to log base a of x. So that is y is equal to log base a of x. So this is the logarithmic function. And what that means is we switch this to exponential form. It's, x is equal to y to the a. Now the exponential function is y is equal to a to the x. And then you see this is the exponential function that we learned from the section before. This is a new function. This is the logarithmic function. All these three things are the same thing, right? All these three are the same. This is the exponential function. These two are very different. However, the relationship between them is you see how the x and the y are flipped. X and y are flipped. So what the logarithmic function is it's just an exponential function, but you flip your x and your y. So that means that exponential function and logarithmic function, the inverses of each other. Okay, that is a really important thing for you to remember. An exponential function is the inverse of the logarithmic function and vice versa, right? So to understand the logarithmic function, we look at the exponential function. We learned that already. Domain is all real numbers for the exponential function. Range is y is larger than 0. So when you do the logarithmic function, the domain, you swap the x and the y, right? So the domain is now the range. The range is now the domain. So the domain is the range of the exponential function. So y is larger than 0. And the range is all real numbers. So you swap them. Okay, that is the key understanding that you got to have, is that the logarithmic function is inverse of the exponential function. Okay, these are the key findings that you really need to understand. The domain and range swap between the two functions. All right, so if you want to find the domain of a log function, one thing you can do is, since it's the inverse of the exponential function, just find the inverse. Find the exponential function, and then find the range of that, and then swap it, right? So here, I'm just going to find the inverse of this, right? So I put y in for f of x, and then I change that to exponential form, and then I swap the x and the y. Now I have the inverse, right? And I solve for y. So I subtract 3 by both sides. Okay, I'm going to slow down one more time. I change this to just y. So this whole process is finding the inverse, okay? And we did this before. You put the y in for f of x. And then the new thing is I switch this into exponential form. And then to find inverse, I swap the x and the y. Right, swap the x and the y. So I have 2 to the x equals y plus 3. Now I solve for y. So now I have the inverse. F inverse of x is 2 to the x minus 3. Now here, my domain is all real numbers. My range is y is larger than negative 3. I take these and I swap them. Then I have the domain and range of the original function. So the domain is x is larger than negative 3. I took that from the range. And the range is from the domain, so now it's all real numbers. Okay. The easier way to do this is take the argument of the log, okay, which is x minus 3, the x plus 3. So you take the x plus 3, and that has to be larger than 0. And that would be your domain. So you solve for that, and you get the domain. Okay. We'll try that one more time. You find the domain of this. Take the argument 2x plus 5 has to be larger than 0. So you solve for that. X has to be larger than negative 5 halves. Now let's graph these guys. So it's kind of hard to graph log functions, right? Log is kind of confusing. There are ways to do it. You plot points. You can plot points. You can memorize the 3 important points, like how we did with exponential function. I think the best way to do this is to use the inverse and graph it. All right, so here I have this function here. I have y is equal to log x minus 10. And remember, log is base 10, right? So switch this to exponential form. Now you have base 10 to the y is equal to x minus 4. And from that, I'm going to find the inverse. Okay, so the inverse, I'm going to swap the x and the y. So, of course, I have y minus 4 is equal to 10 to the x. You see, now this is a lot easier, see, because you're solving for y, you don't want y to be the exponent, you want y down here. So then it's just add 4 to both sides. Here's my inverse. Y is equal to 10 to the x plus 4. It's just a regular exponential function. Now I do the parent function, which is y is equal to 10 to the x. Then I do my 3 points, negative 1, 1 over 10, 0, 1, 1, 10. And then I do the transformation. Of course, I have to add 4 to the y's, right? So add 4, I have negative 1, 4 and 1/10, 0, 5, 1, 14. And then domain is all real numbers. Range is y is larger than 4. Horizontal asymptote is y is equal to 4. See, all the easy stuff that we've done before. Do the inverse. Do everything you know. Graph the inverse. Okay, I'm going to graph the inverse here. There's my horizontal asymptote. With the 3 points, I get my function looking like that, right? It kind of curves up like that. It's really hard for me to sketch this on the computer, by the way. So it doesn't look exactly the way it should, but it looks kind of like that. It keeps going forever. Remember, the domain is all real, so it actually goes across like this. It keeps going to the right and the left forever. But that's my curve. Now, how do I graph the actual function? Because I just graphed the inverse, right? This is the inverse. To graph this function, I just swap the x and the y. So I take my 3 points here. These 3 points, after the transformation, I just flip them. So now my 3 points and my domain range, I can switch the domain and range as well. So actually, let's do that first, right? So the domain is now x is larger than 4. That's from the range here. And the horizontal asymptote is x is equal to 4 from, not horizontal, the vertical asymptote, sorry. That should be vertical asymptote is x is equal to 4 because I got that from the horizontal asymptote. You see, you just swap them. It's y is equal to 4. Now it's x is equal to 4. So here's my vertical asymptote. X is equal to 4. And then there's my domain is on the right. X is larger than 4. And then I take these 3 points and I swap them. Now I have 4 1/10 to the comma negative 1, 5 comma 0, 14 comma 1. And then I sketch that and I get this graph, right? Get this graph. So the black one is my actual graph. The red one is my inverse. We'll do one more. Here is log base 1/2 of x plus 3. So let's put y in there so it doesn't look all confusing. Put it in exponential form. So 1/2 to the y is equal to x plus 3. I don't know how to graph that. I'm going to do the inverse. So I find the inverse. I switch the x and the y. So y plus 3 is equal to 1/2 to the x. So I solve that. My inverse is y is equal to 1/2 to the x minus 3. Parent function is y is equal to 1/2 to the x. The 3 points. Negative 1, 2, 0, 1, 1 and 1/2. Right? Always same thing when you do exponential. We know exponential. It's easy. So to get the 3 points, now do the transformation. Subtract 3. Well, take 3 from the y's. Now, negative 1, 0, negative 2, 1, and negative 2 and 1/2. Domain is all real. Range is y is larger than negative 3. Horizontal asymptote is y is equal to negative 3. So you take all these things and you swap them and you get your real function. Right? Because now you have the inverse, swap the inverse, and you get the real function. So I take the domain and range, swap them. Domain is now x is larger than negative 3, right? From the range. The range is now all real numbers from the domain. Vertical asymptote instead of horizontal. I know it says horizontal, it should be vertical. Okay, vertical asymptote is x is equal to negative 3. With the 3 points here, swap them. Oh, negative 1, swap, still negative 1, 0, negative 2 is now negative 2, 0. And then swap these, negative 2.5, comma 1. And then the graph comes out to look like that. Okay, this one is your inverse, and this one is your real function. Okay, they look kind of similar because they're symmetric. They're like close to be symmetric on across the y equals x line. So it looks like that. Okay, so that's graphing. Okay, remember it's just graph. Just find the inverse, graph the inverse, and then take whatever information from the inverse, switch the x and the y, and then you have your real function. Solving for these equations. So here's an equation. It looks like that log. It has a bunch of, if you have like x either at the bottom of log as the base of log, or of the argument of log, you can't solve for it. You can't solve for it even with a calculator. So what you have to do, switch it to exponential form. So it's actually 3 to the second power is equal to 4x minus 7. Oh, look, we can solve that now. 3 to the second power is 9. 9 is equal to that. And then you can solve that equation easily now, right? See? All right. Another one, you have x with your log. Every time you have x with log, you can't do it. You have to switch to exponential. So remember base e, ln is base e. So e to the first power is equal to 2 to the x, 2x minus 1. Solving for that, e to the first power is just e. And then add 1 to both sides. E plus 1 is equal to 2x. Whatever, e is like 2 point whatever. You can solve this equation. Yeah, like that. So e plus 1 is 3.718 divided by 2. You get like 1.8, whatever. 3.7. Yeah, 1.9, 1.8. Another example here, I have log base x of 64. Again, you have x with log, can't solve for it. Can't solve for when x is with log, you have to go to exponential. So x to the second power is 64. Now we know how to do this, right? Remember we changed the base and stuff to match. Well, here, what you can do is change it so then the exponent is equal. What to the second power is 64, basically, right? It's got to be 8, right? X squared is 8 squared. So x is equal to 8 or negative 8. Ooh. Anyways, so moving on here, again, you have x next to log. Can't do it. So you have to switch to exponential form. But be careful on this one. This one is not just log, but you have something added to it. So you have to take away the 4 first. See, you subtract 4 on both sides. Now you can switch it to exponential form. Now it's 3 to the second power is equal to x minus 3. You better be able to solve for that, right? Okay. So let's do some more. Here, you have this equation here. There's no x in here. You can actually solve for this. There's no x here. So let's say, what is this value? If I want to find this, I just say, oh, that's equal to x, and I'm going to solve for x, right? So you switch it to exponential form. You have 2 to the x is equal to 33. 2 to the x is equal to 33. And the only reason that I'm doing this, guys, is because I don't have a calculator. And on the test, we won't give you a calculator. We won't allow calculators. We ask you to solve the work without calculator and show the work. So when we do this without calculator, we try to switch to exponential form and stuff. But realistically, if you have a calculator, you can solve for this, right? You can solve for this without doing work. The calculator can do it. Okay. Whereas previously, there's no way that you can do this even with calculator without switching to exponential form. Exponential form is necessary when x is next to log. Okay. Every time you have x next to log, switch it to exponential form to do it. This problem here, there's no x with log. You can actually solve this with a calculator. However, without calculator, you have to switch it anyway. So let's make that equal to x, and then you switch it to exponential form. You have 2 to the x is equal to 33. And then now we're going to try to match the base, right? 32 is base 2 to the something. And then we try to do that. Well, it's 2 to the 5th. So now I know, oh, x is equal to 5. Okay. Next one, again, no x with log. I can do this with a calculator, but I don't have it, so I got to change to the exponential form. So there's exponential form. 3 to the x is equal to 1 to the 27th. Remember, if it's at the bottom, bring it to the top and make the power negative 1. All right. So 2 to the x is 27 to the negative 1. Now change that 27 to make it base 3. So that's 3 to the third power to the negative 1. And then I multiply that in, right? Multiply the exponent with the exponent. And so now I know x is equal to negative 3. Another one here, log base 8 of 8 to the 17th. Again, no x. We should be able to solve this without changing it if we had a calculator. But we don't have a calculator. That's why we're changing it. Just make sure you understand that. So here, 8 to the x is equal to 8 to the 17th. Oh, well, x is equal to 17. That was easy, right? Another one here, ln 5 equal to 2x. ln is base e. Remember, you can put this into the calculator. ln 5, it gives you the number, and you can solve that, right? But we don't have a calculator, so we have to switch this into the exponential form. I have e to the 2x is equal to 5. Now, how do I change the base of e and 5 to match each other? The answer is you can't. You cannot change base e and 5 to match each other, right? So you can't do this. And this one actually does require a calculator. Okay, there's no way to do it without. So you'd put into the calculator ln of 5 is 1.6, which is equal to 2x, and then divided by 2 and stuff. All right. So a lot of people get confused with solving logarithmic function and exponential function. When do you change it? When don't you? Okay, the idea is if you have x next to your log, like these problems here, x next to log, the calculator doesn't help. You have to switch it to exponential form, and then you have to match them or solve them. From exponential form, you should be able to solve these, right? We give you numbers that you can solve them, okay? Typically, we can solve these. If there's x next to log, you can solve it by changing the exponential form. Now, these problems here, there's no x next to log, right? So you should be able to solve this with a calculator. You only have to switch to exponential form if you don't have a calculator. But even if you switch to exponential form, we have to give you numbers that work, like 2 and 32. You can match the base. 3 and 27, you can match the base. 8 and 8, obviously, they're already matching, right? But a problem like this one here, you switch it to exponential form, right? You can't match the base. So you have to fall back to the calculator and put this into the calculator. ln of 5 is 1.6. And then you just solve that.